All right, so we're going to talk about increasing and decreasing functions, telling when functions are increasing and decreasing using the first derivative test. So we are going to talk about some definitions first. Definition of increasing and decreasing functions is a function that is increasing if for any two x values, x1 and x2 on the interval we're talking about, or x1 is the smaller of the two values, that implies that f of x1 is less than f of x2. So what the heck does that actually mean? Like if I draw a picture and I'm talking about some interval that we're talking about here, and on that interval, if I've got an x1 that's smaller than the x2, any two values that I choose, that the function is increasing if every f of x1 is the y value, is smaller than the f of x2. Okay, so it's going up if you choose another x1, x2, that every time you choose an x1 and x2, where x1's on the left and x2's on the right, the x1 is always smaller than the x2, no matter what you choose. All right, so conversely, it's decreasing if x1 is left and x2 is right, means that every x1 is bigger than f of x2. So in other words, if I have my same little picture here, here's my interval, and I choose something on the left and something on the right, okay, that is always, the x1 is always bigger than the x2, so it must be going down. All right, so to test for increasing and decreasing functions on some closed interval, AB, so let's talk about we're going to talk about a function that's continuous on that closed interval AB, and it's differentiable on the open interval. We say that because endpoints are not, we don't know what derivatives are because we don't know what happens on the other side of them. All right, so if f prime is greater than 0, in other words, remember, f prime is just slope. If slope is greater than 0 for every x in the interval, so if slope is positive, then the whole function must be increasing. Okay, so what does that look like? If slope is positive, the function's increasing, all right? If slope is less than 0, so if slope is negative, then the function must be decreasing. On that interval, wherever slope is negative, the function must be decreasing because it's going down. Slope is negative. All the tangent lines have negative slopes. All right, now if f prime equals 0, then we must have a flat line, so a constant function. So the only time you have a slope equal to 0 is if you have a constant function. Now remember, we're not talking about f prime for an instant. We're talking about an f prime on some whole interval is 0. So we must be having a constant slope of 0. We must be a flat line, at least for that little part. You know, maybe it does other stuff elsewhere, but right there it's flat. All right, so we're going to use the idea that if slope is positive, if derivative is positive, the function is increasing, and if derivative is negative, the slope is negative, so this function is decreasing. We're going to use that idea to figure out where the function is increasing or decreasing. Well, it's either the derivative is positive, the derivative is negative, or the derivative is 0. Okay, so we need to find critical points to find the places that either there might be a break in the graph. So for instance, f prime does not exist, might be a break in the graph. F prime would not exist anywhere there's a cusp or corner. F prime would not exist anytime there's a discontinuity. So it's going to pick up all those possibilities where there's a jump in the derivative. Okay, and also our critical points will locate all the places where f prime is 0. It will also locate all the endpoints, okay, because those are our critical points. So we're going to talk about what our derivative looks like everywhere except our critical points, because the critical points are either the places where the derivative is 0 or the derivative does not exist, and we need to know our endpoints so we don't go past them. Okay, so we're going to locate the critical points first so that we know the places where the derivative is not positive and not negative. All right, so first, we're going to talk endpoints first. This is a cubic function. It's an x cubed minus an x squared. It doesn't have endpoints, okay? There are no endpoints there aren't any, okay? This function goes on forever. So we're gonna actually graph not f prime, but the signs, positive or negative or 0 for f prime. So we're gonna use this graph over here. I'm gonna put, since there are no endpoints and the domain goes from infinity to negative infinity, I'm gonna put arrows on that. We'll come back to that in a second, and it'll become more clear why we're doing that. All right, so we need to know where f prime equals 0. Well, we better figure out f prime. So f prime equals 3x squared minus x. Minus 3x. So we need to set that equal to 0. 3x squared minus 3x. I did that by factoring. So I had 0 equals, I factored out a GCF of 3x. All right. Now, if I factor out a 3x, I get x equals 0 from this part. And I get x equals 1 from this part. Okay, so those are our two critical points where f prime equals 0. I'm going to put those critical points on my number line for a second. Those are two of our critical points. Now let's talk about where f prime does not exist. Okay, now remember, here's our f prime. F prime equals 3x squared minus 3x. Is there any place where that function does not exist? No, it's continuous everywhere. There are no more critical points to add for f prime does not exist. It exists everywhere. And if you think about the graph of a cubic, well, it's nice and smooth. There are no cusps and corners. There are no discontinuities. There are no vertical asymptotes. It is continuous everywhere. We don't have to worry about that. All right. So the next step after we have all our critical points and we plot them on a number line, okay, there's other ways to do this, but this is just the most organized. I'm going to label my number line for f prime. So I'm going to find my values for my slope. These two critical points, our slope is equal to 0. So remember, slope can either be 0, it can be positive, or it can be negative, or it cannot exist. Well, there's nowhere where the slope does not exist because we already did f prime does not exist. These are the only places 0, so the other places have to be either positive slopes or negative slopes. So if it's 0 here, slope is either all positive on this part or all negative on this part. So anything less than 0, it should be all positive or all negative. Why? Because if it's not 0, it's positive or negative, and to go from positive to negative, it has to cross through 0. So either all of this is positive, all this is negative, and if it's not, there's some other 0 in here that it would have to cross through, but there isn't another 0 for f prime. We already found all the zeros for f prime. So it's either all positive or all negative. That's probably the hardest part to understand in this. Okay, so I'm going to pick any random number because it's either all positive or negative. You could choose negative 100 if you like. I'm going to choose negative 1 because I don't like using big numbers. I'm going to look at my slope or my f prime. I'm going to substitute into f prime, and I'm going to substitute negative 1 in because, like I said, it's a small number, so I don't have to think so hard. 3 times negative 1. If I substitute that in, I get 3 times 1, which is 3, plus 3, so I get 6. It's positive. That's all I really care about. Slope is positive. If you had picked negative 2, if you had chosen negative 2, you would have gotten 12 here, okay? And if I had negative 2 here, you would get plus 6. Again, it's positive. It doesn't matter what you choose, you're going to get a positive number. All we really care is no matter what you choose in that interval less than 0, you're going to get a positive number, a positive slope. If your slope is positive, you must be going up. In this interval, okay, in this interval here, your function f is increasing because your slope is positive. All right, so now how about this interval between 0 and 1? Well, I'm going to pick any number I like. I'm going to choose 3 times 0.5 squared minus 3 times 0.5. Well, 3 times 0.5 squared minus 0.5 is, so I got negative 3/4 or negative 0.75. So it doesn't matter which number you chose. You could have chosen a fourth or 0.2 or 0.1 or whatever you wanted, but I chose 0.5. Anything on the interval, it's getting a negative slope. So in other words, this part of the graph, okay, in that interval, all our slopes are negative. If slopes are negative, you're going down, you're decreasing. Okay, so let's talk about this next part. So I'm gonna pick any number above 1. So this number is 1, my critical number is 1, that is where my slope is 0. What about on the other side of 0? Is it going down some more, or is it changing and going back up? Well, let's put in 2. So I'm gonna do 3 times 2 squared minus 3 times 2. I get 3 times 4, that's 12. Minus 6, I get a positive number. I get positive 6. So this whole thing has a positive derivative. In other words, a positive slope. If I have a positive slope, I must be increasing. I'm going upwards to have a positive slope. So on this interval right here, I'm increasing. All right, so on AP tests anyway, it is not enough to just say that the derivative is increasing or decreasing. Excuse me, the derivative is positive or negative. You need to explicitly write out in a sentence your conclusions because you know f prime is positive and negative. So, for example, it says write a conclusion to tell whether the function is increasing, where the function is increasing and decreasing is really what we need to know. Okay, so f is increasing. Don't say it is increasing. Be clear whether you mean your derivative or your function. F is increasing from negative infinity to 0. I'm going to use interval notation and 1 to infinity. If you would like to use where x is less than 0 and where x is greater than 1, that is absolutely acceptable. Okay? Because, and this is the important part, because f prime is positive, you can also say that by saying f prime is greater than 0. You don't have to say it, f prime is positive. Either way, it is the same. Now, I'm going to say f is decreasing. Now, be careful. It's not f prime that's decreasing. F prime is not increasing or decreasing. It is telling you the slope of f. It's telling you what f is doing. F is decreasing on the interval 0 to 1 because f prime is less than 0. F prime is negative, if you'd like it to say it that way. All right, so it's really important that you put that together. All right, so the next one we're going to talk a little bit more about when you get strange critical points and just practicing a little bit better at finding critical points and then interpreting your answers.